Okay, PreCal, we are back. I had a lovely lunch, salad with chicken, and that's exactly what you needed to know. And now I'm going to continue these notes. So if you remember, I had an old video that covered this. I just made a video that did number 2, and now I'm on to number 3 with this exponents and logs. So on this one, notice that they tell us. All right, sorry. Now lunch is over. Notice they're telling us what the parent function is. And so that's very helpful because it gets a little confusing when we don't know that. So here, what we know is that that log base 3 of x would look something like, it would have the point 1, 0. And then it would, when I plug in 3, so log base 3 of 3, would equal 1. And so I have the point 3, 1 right here, and then so it would come up through here and come down this way. So that's what the parent function would look like. So here, ladies and gentlemen, this one, the parent function is this. So we need to figure out what did we do to change things. I can see that there is a reflection over the well, so it looks to me like what they did is they took this this one in green and they reflected it over the y-axis. You know what? I need a new color. If we reflect it over the y-axis, then we'd have the point -1, 0, and we'd have the point. This is the point 3. You know what? I'm gonna label that. This is the point 3, 1, this is the point 1, 0. If I reflect them over the y-axis, I now have the point -1, 0. I may write over, and then I have the point -3, positive 1. -3, positive 1. Okay, and so then that does something, well, and we still have the same asymptote. Pretend I can draw. Okay, and that's been that reflection. However, that's not where we are. So what we have done is we have come along and we have moved this right 2 and up 1 to get to that pivot point. So what I know is that I've got, but even so, I'm going to have, then this, let's see, if this point moves to the right 2 and up 1, did this point move to the right? This is -3, 1, and it moved it to the right 2 and up 1, and that does land us on this point right here, which is good news. So what we can say is that this is y is equal to log base 3 of, we had a reflection over, to go from the green to the red, we went over the y-axis, which means I need to make a negative in here. So a negative, and and then we had an x. We went to the right 2, so then that becomes a -2, and then we went up 1 right here. Let's verify, you know what, actually, let me say f of x. That way I can check to see, okay, what would f of -7 equal? Because it could be that we've got we should have an a value here or a b value in here. I'm not sure, and so we might just have had these reflections and shifts. We might also have a stretch. The stretch would be a bummer. Here's hoping we don't. But what we can do is we can check to see if I plug in that extra point that I have, this -7, 3, what do I get? So coming along here, I would say, okay, log base 3 of -7 minus 2 plus 1. Well, this is equal to log base 3 of, well, a -7 minus 2 is -9. Make that a -9 is now a +9 plus 1. This, hopefully you recognize that, that this is equal to log base 3 of 3 squared plus 1. And our log properties allow me to say that this is just 2 plus 1, which is indeed equal to 3. Was that what we had? It sure was. We, ladies and gentlemen, are done. That is the answer to this. Okay, I've made a mess. That's the answer. Right there. Dude, maybe I'll do this. That was fun. Okay. Let's look at the next one. This one, they're telling us that we have a parent function of, let's start with green like I did a second ago. We have a parent function of 3 to the x. So what I'm going to have here is I'm going to have the point 0, 1. And then when I plug in, I can make a little table if I'd like. when x is, here's x, here's 3 to the x. So when I plug in 0, I get anything to the 0 power is 1. I don't know why it gets jaggedy like that. Okay, plug in 1, I obviously don't use this properly. Plug in 2, I get 9. Plug in 3, I get 27. I don't care about 27. Okay, so then I have the point 0, 1. I have the point 1, 3. Oh, okay, I have the point 2. 9 is going to be up here somewhere. So this is what the parent function, oh, okay, I missed. There we go. That's what the parent function would look like. This is the parent function. So now notice what we've done here. We had an asymptote of y equals 0. Well, now it sure doesn't look like we have an asymptote of y equals 0. It looks like we have an asymptote perhaps of y equals 2, maybe? Let's see what happens. So what we've done is we have now taken that graph and we've reflected it over the x-axis. And so here would be the pivot point if I reflect it over the x-axis. That's the point 0, -1. But then, now I can't see the stuff I did underneath this. But now what they're telling me is that the pivot point is -3, +1. So I have to go left 3, let's use the right thing, left 3, and then up 2 to get there. Oh, goodness gracious. Okay, so we went left 3, up 2, after we reflected over the x-axis. Okay, so that means, okay, sorry about this mess, that bothers me. That means that we're going to take our parent function, so this g of x, did I call this one f of x when it was called, do you know what, let's change that. Let's call that g. Oh, how about I not erase g, that's g. Okay, so that it has a new name, because this they said was f, so here's g. Great, okay. So I have f is this 3 to the x, so g of x is going to have a reflection over the x-axis. We put a negative here. We're going to go left 3, so that becomes x plus 3, and then up 2 right here. So now, let me get rid of all of this. Oh, all of this mess. Delete. Okay, I still have delete. Delete. Okay, now I can see the graph a little bit better. Notice if I plug in -3, that does become my pivot point. Oh, I forget. G of -3, this becomes -3 to the -3 plus 3. This becomes plus 2. This is -3 to the 0. Keep in mind, this is negative. 3 to the 0 is 1. So that's how we get, this is -1 plus 2 is a +1, and that's how we get that pivot point of -3, 1. Now let's verify to make sure we don't have any sorts of stretches. That would be annoying. Hopefully that's not the case. So let's check g of -2. And so if I have g of -2, it's -3, and then raised to the -2 plus 3 plus 2. This is -3 to the 1. Well, -3 to the 1 is, well, -3 to the 1 is 3, so that's a -3. And this is -1, and sure enough, g of -2 is equal to -1. So the correct answer for this is right here. Let me make sure that you understand that there is a big difference between -3 to the second. It's not the same thing as -3 to the second. Okay, this is saying -3 times -3. This is saying -3 times 3. They're not equal. This is a +9, this which is not equal to a -9. So point being, the square just affects what it's touching. So if you want the square to affect that negative, you got to put it in parentheses like we see right here. Okay? Hopefully that is something you already knew, but if not, I want to clear that up for you. All right, good luck. Go practice. I think, did I do? Yes, so this one was not actually, this was a Ms. Deloach ad, so thank you, Ms. Deloach, for adding this to our notes. The rest of it, it's kind of mixed up and whatever, but you can find it. You can solve your problem. Good luck. Let me know if you have questions.